presentation is Drive for Show, Putt for Dough. This course was offered in spring 2017, and this is our teaching staff. Drive for Show, Putt for Dough is a common golf expression that refers to the idea that golfers who excel at the first shot on every hole, the drive, generate the most excitement. But golfers who excel at the last shot on each hole, the putt, win the most money. Is the expression true? Or does some other aspect of the game separate the big money winners from the rest of the pack? Let's put Python 3 to work and find out. In this video, I will answer these questions with 3 summary charts based on data from the Professional Golf Association. I'll then review the process, code, and data that were used for this project. But first, a bit of a spoiler alert. It turns out that Drive for Show, Putt for Dough is a myth. This chart shows that being great at driving is more important than being great at putting when it comes to winning money. Specifically, the chart shows the correlation coefficients for lots of dough, great at driving, and great at putting relative to lots of dough. Lots of dough is perfectly correlated with itself, so its correlation coefficient is 1. Great at driving has a correlation coefficient with lots of dough of 0.46. This is more than the 0.28 correlation coefficient between great putting and lots of dough. In other words, if you excel at driving, measured by strokes gained off the tee relative to other golfers, you will win more money than if you excel at putting, measured by strokes gained on the green relative to other golfers. Maybe the expression should be drive for show and drive for dough. But not really, because 0.46 is a relatively weak correlation. Is there another aspect of the game that separates the big money winners from the rest of the pack? Yes. As we see on this chart, strokes gained, tee to green, has a correlation of 0.64 with lots of dough. This variable refers to the effectiveness of a golfer in getting from the tee to the green in as few shots as possible. It is more correlated with winning lots of dough than either driving or putting. Let's take a look at this variable and put it in a scatter plot. The title of this chart is Strokes Gained, Tee to Green versus Official Money Won. On the x-axis, we see strokes gained. On the y-axis, money won in thousands. Each dot represents a golfer. Using the very cool hover tool from the Bokeh library, we can take our cursor and hover over any of the dots. When we do, we see the player's name, in this case, Jordan Spieth, the number of strokes gained, in this case 1.3, and the money won, in this case $2.7 million so far this year. Not bad for golf. Let's move forward and review the process, code, and data that generated these upfront conclusions. In the next section, I will provide highlights of each of 5 steps. Locate a dataset, import key libraries, read, explore, and clean the data, analyze the data, and create data visualizations. The first step was to locate the dataset of golf statistics. For this, I went to PGAtour.com's stats. Interestingly, the 3 images on the page show the variables we've discussed so far. 1 is a golfer driving, 1 golfer is preparing to putt, and the 3rd, he's hitting a second shot to gain strokes from tee to green. Since the golf stats were not available for easy download, and since Lena has not given her a lecture on web scraping, I needed some assistance. So, I asked my son Jimmy for help. Jimmy's a great golfer and a great computer programmer. He scraped the website for statistics and gave me a CSV file of data. Thanks, Jimmy. The second step of the process was to identify key libraries and import them. When first faced with the problem, I tried this line of code. But it didn't work. Nadad wouldn't be happy. So I went back to the drawing board. In this case, here are the real libraries that were used: Pandas, NumPy, Seaborn, Matplotlib, SciPy, Warnings, and Bokeh. Armed with these libraries, we were able to go ahead and begin the process of reading and exploring the data. In this case, golf equals pd.read_CSV reads the CSV file into a Pandas data frame we call golf. Looking at the info in the file, we see 194 rows and 21 columns. Down at the bottom, we can see that the 5 columns here lack values and are unnamed. We're going to want to get rid of these columns. In addition, the other columns are a little bit messy in terms of formatting. So let's do some cleaning. First, golf.rename takes the columns and puts them in a format that we're going to be more happy with. Second, golf drops eliminates those columns we don't want. Now we have the data in a form that we're going to like better And we can move forward to the next step of the process, which is to analyze the data. The simple command, golf.describe, delivers a wealth of data. For each column variable, we're provided with a variety of summary statistics, and if we pick just one of those, standard deviation, and look at strokes gained tee to green, we can see the standard deviation of almost 0.8, which is nearly twice as much as the 0.43 standard deviation associated with strokes gained off the tee, as well as about the 0.4 standard deviation for strokes gained putting. We're seeing more variance and variability in strokes gained tee to green, which may provide some insight as to the link for money. Let's do another simple plot command, sns.pairplot golf. This delivers tons of charts, which on the one hand might be a little bit overwhelming to look at, but on the other hand, they provide us with the type of information that will allow us to go from 15 variables that we had been analyzing down to the 6 that we deemed to be most important. Now we can go ahead and start to work on some data visualizations. Do you recall the chart from earlier? Drive for show, putt for dough is a myth. Well, here's the code that generated that chart. First, we created a new pandas data frame off the one we'd previously been working with, but that had 3 extra columns. We dropped those columns, put the remaining data frame into correlation coefficient data frame, and then took that past the column official money 1 based on sorted values ascending and ended up with the data sorted from top to bottom. When we went to the next chart, which involved 6 bars, there was virtually no change in the command. We just needed to pull in a different data frame's correlation coefficient that contained these 6 variables. Moving on now to the bokeh hover tool, scatter plot. You'll recall that this contained dots for each player. This was the most challenging part of the code. And when we did this, we broke it down into 3 key steps. The first was to use column data source, which was important in setting up the data to be passed into the chart. The hover tools capability was important for setting up which data was going to display when we took the cursor to hover over the dots. Finally, we took the data and output it into a plot. Now when we go back to the chart, one thing that catches our eyes is that the data seems to be increasing exponentially. In other words, as you increase on strokes gained, you seem to be increasing money winnings at a greater rate. So what happens if we take the log of official money 1 versus strokes gained tee to green, and in this case run the lmplot function? Now we see the points are beginning to align a little bit more closely along a single line. We're seeing a correlation. So what have we learned? Drive for show, putt for dough is a myth. Strokes gained tee to green equals show me the money. Python and golf are a match made in heaven. Thank you, Joe and Naynad, for a great course. I learned a lot and had tons of